Okay, hello everyone, and welcome to quite a special session actually that we're giving today, a 2-hour session, and we have a number of different jugs involved. We have the VJug who's hosting this for the Netherlands jug and also the C jug, and we're going to be looking at Java 9 and what we can expect from the upcoming release of Java. So I'm here, and actually for once on the VJug I will be doing a short presentation with my colleague Oleg. Hey Oleg, how's it going?
Hey people, it's going great. Pretty excited about this session and Java 9 in general.
Awesome. And that's the first time you've ever showed excitement at Java 9. I'm pleased. It's breaking you down. And I'm going to point over to we have the Netherlands jug here, and who do we have here? We have Maurice, we have Robert, we have Jonathan, and we have Bertrand. So hey guys.
Hi there.
Not too bad, actually. Thank you. Looking forward to this session, actually. So I'll pass over to you guys for the intro.
Right. Okay. So you can do it. Yes. I'll briefly introduce, and then I'll give the word to Maurice. So, hi everyone here. Welcome to this joint session by the LN the Chicago jug, and also facilitated by the virtual jug. We're going to do a dive into what's coming for Java 9. We have prepared an interesting program with joint submissions from all three groups. Maurice is going to briefly introduce our program today. So, some of you would like to cycle through the slides. Then we'll be good. Thank you.
Yeah, I'll get out of shot. There we go.
Okay. Well, we know the release for Java 9 has been postponed a number of times. But well, we're actually looking at 40 days from now, an actual release. So we're very grateful for that. It contains no less than 91 Java enhancement proposals. So it's pretty packed. It's not just Jigsaw, a lot more. We'll hear all about that today. And you have already been able to try it out for a long time, but just a couple of days ago, Mark Reynolds let us know that we actually have a release candidate. So this should be pretty good and pretty straightforward to use. So let's just have a go at it. The program for today, we'll start off with, well, it's all very practical. So we get a developer's guide for the practical side of Java 9. Simon and Oleg will be presenting that. After that, Jonathan Ross will dive into the performance under Java 9. After that, we will have Robert Scholte, who will tell us all about what the impact on Maven projects will be. And after that, we'll actually gonna answer some of your questions. So if the live audience or the people online have questions, please let us know. I'll show you how we're gonna gather those questions in a minute. And as a roundup, we have Java EE8 update from Josh Juneau. So basically, if you have any questions during those sessions, just let us know at Twitter. Tweet with the hashtag Java 9. We're just going to hijack that one for a couple of hours. So I'm going to try to answer as much as possible of those questions just between those Java 9 and Java EE sessions. That's about it from us. So back to Simon and Oleg for the first session.
Thank you very much. And I'm just gonna mute Jonathan's. So that's the NL jug. So if you have any questions, please unmute before pinging us. Okay, so I'm gonna do some. I'll probably take up about 10-12 minutes, and then I'll pass over to Oleg. I'm gonna quickly share my screen. Let's see if this is how well this is gonna work. So if I was to do that and then that, oh no.
We see that beautifully. So you're talking about Java modules.
How about that? Does that look good? The Pragmatic Developer's Guide to Java 9. Can you see that?
Yeah, we can see that.
You can see that. Awesome. So I'm Simon Maple at SJ Maple, my colleague at Shalayev, Oleg Shalayev. We both work for Zero Turnaround. let me see if I can give more information about us. So we're both developer advocates. I actually created the virtual jug. I'm one of the leaders there. Therein now. I'm also one of the London Jug co-leaders with Barry Cranford and Martin Verburg, and a few other accolades as well. But I'm very proud to also be a Rebel Labs author, which is the content engine which Oleg himself owns. And this is Oleg.
Do you want me to talk about myself?
Go for it. Go on.
Let's see if I can do that.
You're a very exciting
Excellent.
person. We should hear about you.
I'm easily excitable developer advocate for Zero Turnaround. I'm from Estonia. One of the main responsibilities for me is taking care of the Rebel Labs, which is the Zero Turnarounds blog, where we try to publish all kinds of Java related or JVM related or software engineering in general related content. So if you just go and check it out, I'd be happy. I'm happily signing with Virtual Jug. I'm also co-leader of GDG Tartu. So we are trying to focus on Android, so a little bit related to Java. And if you have any questions at all, you should just ping me on Twitter. I try to be way more social than I would naturally be. So awesome. That's me.
Thank you very much. Well, we don't really need to jump into the Java 9 schedule too much, actually, but we do know 40 days. I didn't realize it was such a nice round number. 40 days till the general availability, so we look forward to that, and that I expect won't slip because it's the week before Java 1, so I suspect marketing will push that one out irrespective. So we look forward to that in just 40 days. Well, a couple of things that we can't really talk about. We're not going to be talking too much detail about performance metrics in this session. I believe Jonathan's going to be talking a little bit more about that afterwards. Experience-based analysis, well, without really testing Java 9 on some real production environments and some real load, it's really going to be hard to give experience-based analysis. And yes, we have just seen a first release candidate, but things can still change. I'm going to start talking about modularity. I'm going to jump through a number of slides first, and then we're going to jump directly to some demo. So modularity, yes, hasn't just been around in Java 9. It has been going for a number of years, actually 9 years or so since we started talking about modularity. Mark Reinhold and co at Oracle started talking about modularity. And really, when we ask about, well, if it's been going so long, does Java actually need modularity? Well, there's two parts of modularity. We have modularity in the platform and we have modularity in the application. Now, when we look at modularity in the platform, we see, well, the platform is pretty big and there are a number of things which we actually don't necessarily need for particular applications. So by modularizing the platform, it means we can pick and choose as to what we really want from the JDK in our application. And we can actually trim down the JDK as a result. This is quite a nice modularized JDK image, which shows the different module. At the very bottom, you have java.base, and that is your implicit module, which contains all your very common packages and code, like your java.lang, your collections, and a number of other things. As you grow bigger, as your application grows bigger, you can add requirements onto these other modules and make sure you have a dedicated or should I say, you only use the modules which you absolutely rely on. Now, applications can be can use modularized code as well. And what we need to be thinking about is we need to think about how we can create boundaries or turn our code into modules. And people will say, well, OSGI does this already. Well, yes, OSGI kind of does do this, but it is not part of the base. And a lot of people do actually consider it quite over complex. Now, arguably, I would say what we actually have today from Java 9 doesn't actually go as far as OSGI, and for a large part isn't as useful as OSGI. But this is one of the considerations which was made, really, when we make use of a platform modularization system as part of our application modularization system. There are a number of things which we might consider useful in our application, like dynamism in our modularity. So modules coming and going, which this is something which is very easy to get in OSGI bundles, but the platform doesn't necessarily want it. So we're really restricted to some of the things that the platform modularity gives us here. But when we create boundaries, we do this naturally in our code. We draw boxes, we draw arrows between them in our design on a whiteboard, for example. So this is how we draw our architecture. But very often when it pushes down to our code, we just kind of write in a non-modular way. And one of the reasons that this has been is because we haven't really had the enforcement. With Java 9, we have both runtime and compile time enforcement. And we're not talking about things like the public, private, protected. This is all kind of class level access modifiers. What we're talking here about is enforcement of how we encapsulate our code, how we say, with this module here that I've got, I want some code to be visible, some code not to be visible, and as a result, I can choose how other modules use me. So good news, everyone, the class path is dead. Well, absolutely not. The class path is not dead. The class path is still around in Java 9, and I believe it will always be around in Java because if you are using Java 8 or before, if you're using the class path in Java 8, you still want to run your applications in Java 9 on the class path. So you can still make use of the class path in Java 9. However, the class path is flat. It's easy to make mistakes. You'll have problems with missing classes, duplicate classes. I'm sure everyone's nodding and been here before. The class path is unreliable. Whereas the module path is something that is new in Java 9. You can choose whether you want to use the module path or not for your application. Now, you will, under the covers, kind of be using the module path because the platform is modular. So everything in all the code in your class path is kind of under the covers being wrapped up in one big module, but we won't go into that into too much depth. So we have this module path, but module path, yes, it's better than the class path in some ways, but there are other problems. For example, you have to define dependencies between every single module. You have to explicitly require the modules you want. There is a lot more thought and a lot more process that you need to go to in order to do this. However, you get both compile time and runtime checking. So if there is a problem in wiring to the class that you're trying to access, you will get a problem with that at compile time as well as runtime if you manage to get it through. So we're effectively more reliable. Now, I talk about better encapsulation. This looks well. It looks pretty unsafe, if we're honest. And the unsafe package, the unsafe APIs, are the APIs which many people have used in the past. And by people, I'm really talking probably libraries and frameworks. And these days, while many people have used the unsafe APIs for good reason, Oracle and Sun before them has always said you're not allowed to make use of this API. However, everyone did. Now, from Java 9, if you enable pure modularity at the platform level, you won't be able to access any of this, even through reflection. However, there has been a kill switch which has been added, and in fact, it will actually permit you to still access that. But this kill switch will disappear in JDK 10. So a lot of the advice has been if you can manage to run your environment with having your permit access, your illegal access set to deny. This is the kill switch. Then you will effectively run using a solid modularity environment that will allow you to migrate further from Java 9 much easier. But I don't want to talk about Java 9 modules anymore. I want to jump straight into a demo. And in this demo, I've got IntelliJ running. In fact, I'm just going to show you what we have running here. So I have a Java 9 services demo project, and here I've actually created modules. These are, in fact, you can see the little blue squares here. These are IntelliJ modules, but they double up as Java 9 modules. And whereas what we would normally expect to see in a .java file is a class and a number of other things, what actually makes and defines a module is a module info.java class. And a module info.java class, it actually has a keyword module which defines our module name. What I would love to have stated here is a version number, but we don't have versions or true versions in Java 9 modules. And then at this point, we can express how we want our module to behave. And this will state how we want other modules to actually see us, what visibility we expect to see from our package level packages in our module, and also which modules we wish to require and which services we wish to use. So in this case, we can see this module org.0 turnaround API exports a package of the same name. And this kind of reverse DNS naming is going to be very common as to how modules are going to be named. This is, in fact, one of the best practices. So here we can see that this module actually exports this package. So any code in this package can be visible by other modules if they mark a dependency to this API module. If we had another package in this module which wasn't exported, that code would be entirely hidden. We wouldn't be able to access it. We wouldn't be able to reflect it. Let me just go talk about what we actually have here. Here in this API module, we have a MyService class. This is just an interface which just has a get message method. We have a consumer and a provider of this module. Our consumer here. Our consumer in this case has two requires. It has a requirement on the API because we're going to be trying to get this, get a service. We also have a requirement on a provider. Please just ignore that because I haven't yet found a way of IntelliJ running with the provider module in the environment when I run. So this isn't actually needed, but it's only currently needed because I haven't found a way to hack this in IntelliJ yet. We also have our provider module, and our provider module has an empty module info. But these module infos allow these to be named modules in the Java 9 runtime. If I actually look at a piece of code, so if I go into my consumer, we can see my consumer class. In the main of this consumer class, we spin round and we try and grab some services. In my services, all we do, in fact, I see what I've done. Let me just do this. That's better. In my class here, what we can do, in our method, what we do is we just spin round, incrementing a counter and printing that out to the runtime. So nothing too extreme here, and that's pretty much it. Our provider. We have a provider import class, and this provider import class implements the MyService. This currently doesn't actually work because we're not importing. We're not having a requirement on our API module. So the compiler is saying this class isn't visible. But what we're going to be doing is we're going to be adding all the required module info.java statements in to allow this to compile. And we implement the get message, and that get message simply returns nothing at all, just an underscore at this point. So I'm going to actually, let me just allow you to see there we go, the bottom of this. So I'm actually going to run it with Jerable so I can actually make changes on the fly. But when we execute this, what you'll see is the counter just spinning around. So where's my consumer? This counter just spinning around and not really doing that much. So here we go, the counter's running around and we're looking for services, but we haven't really actually done that much. So what I'm going to do in my consumer is I want to say that we want to make use of a service. So I'm going to say we're going to use org.zeroturnaround.api.myService. And what this is now saying is I want to be able to do a lookup from the service registry, which is where services in the module platform can be registered. I want to make use of that. And it allows other people to say, well, you know, if a provider's there and a user's there, the JDK can under the covers link them two together. But we still don't have anything. If I go into my consumer, what I want to do is I want to make use of this, which is the service loader. Now, the service loader has been around in Java for a long time, but what we don't have is the ability to load something called the MyService.class. What we haven't had before is the ability to use this, obviously, in a modular way. So what I'm going to do is I'm going to go to the service loader. I'm going to try and load MyService.class together. This is going to provide me with an iterable, which will allow me to grab that message from it. Okay, so I'm going to hit. Whoa, what just happened? There we go. Okay, so I'm gonna, oh, I see what's happened. There we go. I'm gonna hit save on this and build this. There we go. And that's gonna be updated in my runtime, live updated, but we still don't have any services. So what I'm gonna do is I'm gonna go into my provider implementation. I'm gonna say a couple of things. Well, first of all, we need to require the org.zeroturnaround.api to allow us to compile, and now that's actually compiled for us. So this is now all compiling, so our compiler is ready. But what I also want to do is I want to provide the org.0turnaround.api.myService service, and I want to do that with an implementation. So our implementation is going to be org.0turnaround.provider import. So I'll hit save on that. I'll refresh everything that we have, and now what you'll see is what's actually happened is because we have registered this this service, Java 9 under the covers has actually registered us with the service loader, and as a result, I can go over to my provider implementation and add something here in my message. So I can say from, and I'll say plus this dot get class dot get name. I'll hit save, and I'll just refresh that in my runtime by building that. And then all of a sudden, after the JRebel reload, you can see that we're getting all of these updates. So that's how you can use modules. I've shown you how we can export. I've shown you how we can add requirements, and I've also shown you how you can use some services. I don't want to go too much over time, but what I'll actually probably do is show, I'll show you a little bit about some JShell. But I'll pass it straight over to Oleg to actually do the demo. So JShell is a REPL, and a REPL is simply a read eval print loop. And all we do in a read eval print loop is we take a command, gets sent to us, a single command gets sent to us. The REPL will read it, it will evaluate it, it'll understand if there is any response to give to that, it'll print it, and then it'll go back and read for more information from the user. That's all I'm going to actually show. I was going to show you a slight demo, but I am over, so I'm going to pass it directly over to Oleg, who's actually going to show you some real science, and Oleg can show you some fun API updates as well. So if I go here and I click on Oleg, there we go. Oleg, it's over to you.
Hey there. Let's try this. So initially, I wanted to talk also to you about the garbage collection, the G1 GC being the new default garbage collection, but we have no time about that. So just know that if you just migrate to Java 9, your default garbage collection will be G1 GC, which is supposed to be better at the low latency requirements, but it could eat a little bit of your throughput. So test it out before. It behaves, from the application point of view, it behaves the same way, absolutely, right? Because it's a garbage collection. It's like transparent to the application. But the internals, if you are doing any high performance stuff, or if you're relying on the full throughput power of your machines, then be advised to test it out. So let's, this is everything. And then you can Google whatever tutorials and presentations, say by Kirk Pepperdine, about how to tune G1 GC and how to understand better what it does. However, that is everything that we had on the G1 GC because of the time constraints. And I would like to talk to you about the API additions that come in Java 9. And since we have very limited time, I'll just show you a couple of examples right in the JShell, which is a great tool for firing off one-off commands and typing things in and getting a result. So if I type a command in a Java expression in, I will get the result back, and the result will be stored in a variable like that, and I can later reference it the same way. Oops, the same way, and I will get the result back. You can see my screen, by the way, right, Simon?
We can. All looks good.
Excellent. So one of the most exciting things that we have in Java 9, the API additions are, and the most awaited is the collection literals. We really wanted like a very concise way to introduce lists or sets or maps into our code. And we didn't get the collection literals, we got the collection factor methods because it's Java. So now what you can do, you can have the list off and set off and map off methods, static methods on the classes, which return the implementations of the interface that you requested. So if you ever have those double curly braces syntax, you can forget about that. And the implementations of those interfaces are specifically created to be immutable So you cannot change the results of those, but it is a very nice way to very concisely introduce small field data structures into your code, which can make your code much more readable. There are a bunch of API improvements. I will go just through a couple of my favorite. One thing that before Java 9 was absolutely terrible in Java was the process management. And it was very the operating system specific. And it was hard. You couldn't obtain the PID number for your process. You can manipulate your process very well. Well, now what we have the process handle class, which can give you bunch of information about your actual process, not just yours process, but any process that you have. So if you type process handle.current, you get the current the object representing the current thing, and then you can access the command line path and parameters and everything, and it will work on all the operating systems. You can access the processes by the PID. So if I do the process handle, you can see how I type tab to have the auto completion in JShell for me. What was the number? What was the PID for this? Let me just see. 5623. 5623, and I get the same process handle back, an optional actually. And then I can introspect what processes am I running. You can run sub-processes from the JVM easier. You can handle them, and the API doesn't stop there. So it's pretty cool. Let's talk about optionals. Optional got a couple of very welcome additions, like methods to if present or else, where you can specify runnables to be executed both at if the optional is present or if the other branch is hit and the optional is actually empty. And those were lacking from the Java 8, and that made the Java 8 code with optionals a little bit clumsy. So you had to sometimes check if the optional was present, and then you introduce the checks for that, which seemed almost like handling nulls. Now optional is a little bit better. But one of the most important things that optional got is the conversion to stream. So if I say optional of and say 1, I get my optional of the thing. And now I can turn that into a stream. And I get a stream. Why is this important? Because previously optional had a map function. And the map on the optional was you supply a function, and then that function is executed on the value inside optional. And that was executed eagerly. So if I do map, and then I say map x plus 1, should be that, I get an optional of 2. So map on the optional was eager. Now you can convert to the stream and execute the same map on the stream, and the map will be lazy. So you can check it out very easily in JShell as well. So 13, which is my reference pipeline implementation, and I do map, and I do the same function. And you can see that we do not iterate through the whole thing. We just get a lazy variation of that. Other things that are very cool in Java 9, we got some improvements to the completable features. So if you do concurrency code, you are welcome to check those out. I'm sure there was plenty of examples on the internet. I know that we published a blog post on Rebel Apps about the API changes, which you're welcome to skim through. There were a couple of more things, but I will just do the last example. So try to think about this. The variable thing is, the variable identifier is underscore. So what will happen if I type this? It should compile, and it would compile probably, but not in Java 9. In Java 9, the underscore, single underscore, is a keyword, and you cannot use that as the identifier. So you have to use double underscore to do that. So something like this will compile. You, of course, need a type annotation to say it's an int. But this is something to look forward to. If you use code where you were witty enough to use the underscore to signify the parameters, to mean parameters that it's easy to ignore, then you are in bad shape. Other things that you can look into, you can have the static methods in interfaces now. So now with the default methods in interfaces and static methods in interfaces, you can combine the logic, not static. Static methods were previously possible, the private methods in interfaces. So if you have multiple default methods, you can extract the private methods inside the same interface. And it's pretty cool. Oh, and then the last one, it's kind of hard to show in JShell, but it's very interesting. You can use effectively final variables inside the try finally blocks with try with resources. So if you open some socket or a file channel somewhere inside the try block, so you do try and then, I don't know, what do you have? You don't have to open stuff here, so like file channel here. You can open it somewhere above, and then you just reference it like that. And then in the final block, it will be automatically closed by Java 9 for you. So I'm over time, so I think this is a very short introduction, just a couple of things that could trigger your attention and take your interest. And if they did so, that's excellent, because API is something that all developers will be using throughout the day. Modules, some people care about them, some people don't care about them, some people are afraid of them. Garbage collection may be not your thing, but the API is something that you will be touching daily. So to me, this is one of the most important things in the Java 9 release, and I hope you'll be using that and you will learn a lot about that.
Awesome. Thank you, Oleg. Next up is Jonathan. And while actually we set Jonathan up, just a quick question for you, Oleg. What is the purpose of the underscore now going from Java 9 forward?
That's a good question. Currently in Java 9, it is just a resort keyword. So you cannot use that, but that doesn't mean anything else. Going into the future, there are plans to turn that into the identifier to denote the ignored parameters, default parameters. So if you have functions, a function that takes 2 parameters, or you implement something, and you know that one of them will never be used inside the body of the function. So say you implement a function of 2 arguments, and then you just return the first. If you're implementing the car from Lisp, then you just denote that as the first parameter will be named, and the second is just underscore, and you don't have to specify that in Lambda expressions. Simplifying your code a lot. But that is Java 10, and given the performance with Java 9, that could be a couple of years.
Well, we shall see. Time will tell. Right, passing over. Thank you very much, Oleg. Passing over to Jonathan now. So you're currently muted, Jonathan.
There we go. Can you hear me now?
We can. Awesome.
And can you see my screen?
We can, yes.
Righty-ho. Well, hi everyone. Thanks for having me here. We're cheating a little bit here. I'm actually from the Chicago Java user group, not from the NL Java user group. I just so happened to be in this neck of the woods, and I actually also so happened to speak Dutch. So it's almost like we planned this, the NL Jug and C Jug combination, but no, it's just pure coincidence. I am a senior software engineer. I work for IMC Financial Markets. We're a high-frequency trading firm, a proprietary trading firm, based in Amsterdam, Chicago, and Sydney. I'm also an executive board member of the Chicago Java user group, and I'm also a JCP member. Let me see. So I'm going to just highlight a couple of things. I went to the trouble of going through the very long list of features that made it into Java 9. One of the advantages of the release taking so long is that actually it's jam-packed with features, particularly a lot of things under the hood changing, but also from a performance point of view, there are a lot of things. So I cherry-picked the JEPs from the final release thing that I found interesting. I don't have enough time to go into all of them here, and indeed, if I would, it will probably take a long time to talk about them. I'm just going to highlight a couple of these. This slide is just pretty much the things that will be affecting you in the JVM and a little bit in your day-to-day programming. Sometimes maybe not in your day-to-day program. The right right-hand side here, the variable handles, enhanced method handles, that's more for library writers, or if you're really into your performance tuning the way I am, if you're wanting to do a lot of algorithms and everything like that. There are plenty of other people talking about reactive streams and everything like that, so I won't go into JEP 266 at all here. I'm going to focus on a couple of other ones. But there's not just the stuff in the JDK. We've got a lot of changes in the JDK regarding tooling and tuning issues, tuning things. Actually, there's an experimental support for AOT compilation, which is only available in Linux. Doesn't support compiling client code yet, but you can run the whole base module using AOT compilation on Linux. Basically compiles it down to C1 level from a shared object. And then it just gets profiled like any other code, so it can actually get jittered to C2. It's, I haven't played around with that one yet myself. Let me see. Another interesting one is the compiler control. Of course, everybody's going to be bidding lists like crazy. It's going to allow you to give inlining hints for methods and stuff like that. They've introduced a new file format for that. It's using basically a JSON-like version, JSON with comments, shall we say. So it's officially supported now. That's the other big news there. Actually, interesting is that you can also tune this runtime. So they've added support in JCMD for doing the compiler control. The question here?
Java virtual machine basically decided itself how to inline methods and things.
So the question here is, he thought that the Java virtual machine decides for itself whether to inline methods and things. That is still perfectly true. It's more like hints. You're providing the compiler hints. I'd really like it if you'd inline this method, please, kind of thing, that kind of thing. And there are also some internal hints that you can give the compiler, and that's heavily used in the JDK. If you look through the JDK code, there's an awful lot of annotations in there, which they're then feeding into this mechanism, as far as I know.
Because I thought you were really bad at providing hints.
That's true, and actually a lot of developers tend to be really bad at providing hints. There's no inline keyword, there's no actually user space annotation for this, but if you want to do that kind of tuning, you can actually do it by this file. It's rather like the old, what's it called, the hotspots compiler file. I don't know if anybody's familiar with that, but that was an unsupported API for pretty much to compile things. That was the only way you could really use it, which is great if you've run into a compiler bug, a JIT compiler bug. So that's actually one of the primary use cases for this as well. But there's also handed hints, please inline this method. Anyway, I just wanted to give you actually just a bullet point list of the many, many things that are going on here. So I'll just skip ahead. I won't talk about garbage one. There are plenty of other talks about that one. Unified logging is going to be a headache for a lot of toolsmiths. I suppose they've had plenty of time to prepare for that one. Smart Java compilation, I don't know that much about it, but it's sort of like an experimental thing. S-Java C is an experimental compiler that basically, as far as I know, fires up a daemon and allows you to do parallel compiling and stuff like that. I don't know what state it's in right now. Anyway, back to about here. I'm just going to take a couple of these issues here. The one on the left-hand side here, the points on the left-hand side here are more likely to affect people in their day-to-day developers. About compact strings, and then I'll tell you a little bit about the indefined string concatenation, and then if I've got the time, I'll talk about variable handles as well. One of my favorite features of Java 9, actually. But anyway, so starting off with compact strings. Basically, Andrei Shipilev, or Alexei Shipilev, and Charlie Hunt, and the whole team at Oracle have been working on this for quite some time. They had a database of lots and lots and lots of sorts of Oracle clients, virtual machines, and they did a really big investigation studying the heap dumps. And they found that, say, 10% to 45% of the data in the live set in your typical JVM turns out to be strings. And indeed, the vast majority of those strings turn out to be actually Latin 1, which I don't know if you know your Unicode. Latin 1 is the first 256 bytes. It's the code page at the beginning. So basically, we're storing all these strings in cars, which is 2 bytes, when we could actually get away with storing them in just in bytes instead of cars. And so they did their due diligence. They did an awful lot of stuff. Of course, they did a lot of micro profiling, micro benchmarking with JMH. Actually, another exciting thing about Java 9 that JMH is shipped with it. And anyway, so what did they do? They added an extra little byte to string, and they changed its internal implementation from car array to byte array, which is actually a change which doesn't affect the specification of Java at all. It is implementation detail. So as a user, you don't notice the difference at all whatsoever. And you might think, okay, adding a byte to it might actually be adversely affecting my memory footprint. But as it turns out, due to memory alignment on modern day CPU architectures, 64-bit JVMs at least, there was enough space to put this in. There's between 8 and 16 bytes free space because of memory alignment. So they put in this extra byte. It just says a 1 or a 0, and they detect at runtime when you're constructing a string from a raw byte array or car array. That's when you're going to be doing your compaction or indeed flagging, okay, no, this has got a Unicode character in it that's not Latin 1. And basically, they did their due diligence and they did all their profiling. They got actually what was it, 10 to 25% reduction in memory footprint of a lot of their benchmarks. And as Charlie Hunt was putting it, it's like usually you've got trade-offs between latency and memory footprint, and usually one's got to give. With this project, they actually managed to improve on all 3 of those, which is quite remarkable. So string was already highly optimized for the car array implementation. Well, they had to go and redo all those carefully coded SIMD optimizations and do them for the new layout. So that was the brunt of the work. It was actually coming up with the right optimizations for the internals for the strings. But they did. I mean, obviously they can't go around profiling everybody's apps for them, so they just used micro benchmarks for representative cases, and they saw good enough improvements there. So you can expect, basically, when you switch to running in Java 9, of course, compiled against the Java 9 JDK, you will be using the new byte array version. You can expect that your applications will have less frequent garbage collects. That's the thing, right? Because the allocation pressure will be quite diminished. It can be up to like 50% less allocation pressure. So if you're doing your JSON stuff or XML or whatnot, or indeed just class loading, classes after all have lots and lots of strings in them, it's going to be a hell of a lot faster. So the size has also the advantages of it fitting into cache lines and everything like that if it's shorter. And in the previous slide, I was pointing out that most of the strings are really small. So if you can actually stick that byte array in the cache line, then you're going to get better performance as well. So that's pretty exciting. Another major improvement in how strings are handled in Java 9 is the fact that the string concatenation is now no longer using the string builder. They're using undefined string concatenation, as in they're using the Invoke Dynamic instruction. So Invoke Dynamic was, of course, added in Java 7 as part of Project Da Vinci for the dynamic language people, dynamic languages in the JVM. And in Java 8, the Oracle engineers found out how absolutely wonderful it is for the indirection. Basically, I can decide later how I'm going to, in this case it was lambdas, how I'm going to define a lambda. You can basically defer that to runtime. And so they thought, hey, that worked well for lambdas, let's try it for strings as well. And so now in Java 9, you will no longer find your bytecode being a string builder direct operations. Instead, it will be an Invoke Dynamic command. So if you take your archetypical string concatenation here, I'm concatenating an argument to a constant. It will quite elegantly compile to a single Invoke Dynamic call. Of course, the compiler will also emit a bootstrap method, which is the way Invoke Dynamic works. The classes have to define a method which is invoked once, which will return a call site, which is then used from there on in the program. So the beauty of using Invoke Dynamic is that you can use any number of strategies to actually implement it, and you can basically change your mind from one minor release to the next. I mean, you saw that with lambdas as well. From the very early releases of Java 8, from the U20 release to the U40, you saw a massive increase in the performance of your typical lambda operations. So this is what it used to look like, right? So if you were to compile that same method in Java 8, and actually it was introduced in Java 6, I think, the string builder pattern. It effectively does exactly the same thing as that snippet of code at the bottom of the screen there. What's wrong with this, you might say? I mean, everybody tells me I've got to use a string builder, and hey, why would I bother with string builders? Because concatenation does string builders anyway. Well, the problem here is that if for long strings, if name was a very long string, the string builder would actually have to resize its buffer internally. Yeah, just like with presizing your collections, you've got to also presize your string builders if you want good performance. And so in the Invoke Dynamic versions of this, it actually goes the extra mile and works out how long the string's going to be. And so the default strategy that's shipped with the JVM, the one that on by default is this MHSB sized exact. So that's the using method handles to emulate string buffer behavior, but it's doing exact sizing of the buffer that it's concatenating into. There are 6 strategies in there. I haven't actually tried out the different ones, but you can actually choose different ones from the command line. But the default one gets speed ups of 3 to 4 times that of the other one. The other ones that are in there, there are a couple which do bytecode, which do a spin up bytecode. The method handle way of doing it is the way of the future. So that's another exciting feature of Java 9, really. The method handle improvements that are going into the Java 9 basically allow you to do away with all your old ASM code. You can basically spin up any code on the fly using the method handles. That's pretty much it regarding the identified strings. I just want to briefly talk about var handles. Now, this is not something that will probably be used an awful lot by a lot of developers in their day-to-day development. But if you ever found yourself wanting to implement a lock-free algorithm, or if you're ever using atomic java.util.concurrent.atomic constructs in your code, then maybe it would be interesting to look at var handles. So I actually think this probably a spin-off. Maybe somebody else here can correct me, of the whole Jigsaw project, because they were modularizing the JVM and they wanted to make the internals private. So that included some MISC unsafe. So that was basically a private API that everybody was using anyway, in spite of big warnings around it. Do not use this; it's unsafe. So when they made that private, of course, that broke an awful lot of projects. It turns out that an awful lot of people actually use some MISC unsafe. So the var handles project was born out of a desire to give you that kind of operations, but with the normal kind of safety. Okay, do I actually have access to this variable and that kind of thing? So the aims of the project were to give you concurrent atomic-like operations on fields directly. Why would you want to do that? I mean, so I'll skip that slide and come back to it in a second. This is your typical pattern, right? If you're using the atomics, you might have a field which you wanted to use as a counter. This just as a toy example. The problem with using this is that it's actually chasing pointers. It's actually the atomic long itself is a Java object, so it is a reference. So it's quite a heavy cost to pay for being able to atomically update this field. I would have liked it just to have been a primitive, just laid out nicely with all my other primitives in my class, and be able to access it on its own as an atomic field. So with variable handles, It looks a little bit ugly and everything like that, but yeah, it's definitely a lot better than using some MISC unsafe. That was a lot uglier than this. But you basically use the method handles lookup to find a var handle to the variable, and then you can access it for arbitrary class instances. So down there, if you look, for instance, at the increment method, I'm taking that static counter handle member and I'm pointing it to the object that I'm working on. So I actually have private access to that field, so the runtime will be checking that for me, and then it's going to be incrementally adding 1 to the counter variable. The point being here that oh, actually, you might wonder how on earth is it doing this? Well, it's using something called signature polymorphism, which is something that was already introduced for method handles. It's basically you might say, a dirty little trick inside the JVM. There are certain blessed methods which look like they take an array of objects and return an object. But in the runtime, the JVM sees that and it says, you know what, I'm going to actually spin a method here, a call site, which has got exactly what you asked for. So in this case, we're asking to say, okay, call a method or access a variable with a long argument in the increment method, but in the get method, we were asking it to return a long. The compiler sees these statements, and then it basically weaves up a version of these methods of get volatile and get and add that actually match exactly what the call site was asking for. So I'm passing in a primitive long, and I'm getting a primitive long back. So yeah, there are similar constructs in method handles. Invoke exact is an example of that. So yeah, just going quick back to that slide discussing the features. So just like with the atomic classes, the atomic long, atomic int, there's a bunch of different access modes. So you can just do kind of like read fences, write fences, and all sorts of different semantics. You can also do things like grabbing a volatile field and accessing it as if you were actually just doing a plain old write or store. So omitting using any memory fences. So and it's got all the things that you'd expect from something which is giving you an API for atomic access. So it gives you a get and set, get and add, get a compare and set, and you name it. I like this a lot, and I'm going to be going through my code base and changing it around as soon as we switch over to 9. Yeah, so here's a slide with just a couple of extra links about those things. Of course, you can just read up about them on the JET pages themselves. But there's also some nice little blog entries and presentations. Of course, a plug there for the Chicago Java user groups presentation that Charlie Hunt gave us about the compact strings. And I guess that's about it for what I had to say about performance features in Java 9. So I would hand it over now to whom?
It's Robert.
To Robert.
It's Robert.
Yes. Mm-hmm.
So, everybody ready? Everybody ready? So my name is Robert. I'm the chairman of Maven, and I'm also a member of the expert group for the JShell.
Can I stop you there just quickly? We've got a echo coming in. I think it might be. Maybe if we mute Jonathan's.
Yes. Okay. So what I'm going to do is because I have only.
Sorry, can we unmute either Jonathan or Robert, please? Can we unmute Robert?
So I have to start all over again? Okay. No problem. So my name is Robert Scholte. I'm the chairman of Apache Maven, and I'm also a member of the expert group for JSR 376. also known as Project Jigsaw. And what I'm going to do is, I'm not going to show you any presentation, because we only have about 30 minutes. I'm going to do some coding, just to show you all the things that you will hit when you are trying to switch to Java 9. Yeah. So what I did is I picked up quite an old example. This is a Hibernate Spring project, very small, and it's used in for the book Maven by example. So I think this is about 6-7 years old. It still depends on Java 5. So we're just going to try to run this with Java 9. So here it is. So we have the latest Maven version. It's, right now it is running on Java 8. So first let's have a look if it simply runs. So no surprises here. You see right now quite some warnings, and normally you wouldn't see this because everything was white, but now we have colors in Maven, so now suddenly you see that some properties weren't set. But anyhow, the application is running. So let's see what to do. Let's run it with Java 9. So what do we see here? Right. So Java 9 only supports Java 6, 7, 8, and 9. And since this is a Project 5 project, we have a small issue, but we're going to do it anyway. We're going to make use of tool change. And tool change is, it is actually an XML file, which is located either in your .m2 folder or next to your config folder of your Maven. This is supported since, I think, 3.1.1, at least that you have 2 locations. The tool chain itself was already supported in Maven 2. And what you do in Maven tool change is you specify the type, which is in this case JDK, also a version, and then you specify the location where it can be found. So in this case, I have 2 installations, Java 8 and Java 9. Okay. Also, what I did is here we have the Maven compiler plugin. And here I'm going to activate the toolchain. And what I'm saying here is that I want to use a toolchain which version matches either 1.5 until 9. 9 not included. And let's see what's now going to happen. A lot of stack traces, but let's first see in the beginning that it is really picking up the right toolchain. So in this case, it is not picking up Java 9, but it's using Java 8 to compile this code. But then when the Maven jar plugin is executed, it will get it's actually an area out of bound exception. And the reason for this is that it's Project Verona. Project Verona is a project where they changed the version scheme. I have here the specifications. And you see all the early versions always started with 1.867. So what we did in the code is we always splitted the string on the dots and took the second element. But now we have a new version and it's simply 9. So that's the reason why if we're going to split it on the dots and take the second element, we get the index area of bound exception. Well, this has already been fixed, and what you can do is simply upgrade to the latest version. And let's try it again. So this is looking much, much better. And after about, I think, 10, 11 seconds, we should be ready. 14 seconds. Okay. So right now, we compiled our code with Java 8, while Maven itself is running on Java 9. So this was one of the misconceptions. It seems the #1 misconception that Maven isn't running on Java 9. Well, actually, Maven 3.0 already runs on Java 9. So if I do it again like this, I will get actually a small issue, because like I said, this toolchain support wasn't introduced yet in Maven 3.0. But what I can do is set for this instance the version to Java 6. And as you can see, I'm using release and not source or target. And that's also a new feature in Java 9. And that's called compile for older platform versions. The reason with this is because it could happen that if you compile your code and you compile it with Java 8, but you actually want to be able to run it only on Java 5 or 6, that some code is, let's say, leaking into that code. So I was always using lambdas or streams. If you are using streams, that's available in Java 8. But if you have your code and you have the source and target on 6, it will compile fine. But at runtime, you will see those issues. And with this release option, you will be safe with that. So it will really run, if you say it's release 6, it will compile actually with only Java 6 code, and it will run on Java 6. So that's maybe, for me, more important than the jigsaw feature. So let's see. It was running fine. And we're back to the latest Maven version. And there was also another warning here. And this this has to do with the unsafe part where Jonathan was talking about. This is quite an old version of the Maven War plugin, but we were able to fix this. So again, if we run the latest version, run it again, we'll see that the warning will disappear. This is actually one of the things where other builders are having problems, and this also means that Maven itself is not doing really weird stuff. It's not using the SunMISC unsafe code. So we are quite good. And like I said, the Maven War plugin is not giving the warning anymore. So what can we do next? Well, let's try and add a module info file. So this is what we are going to introduce. But first, you actually want to know, of course, which will be the names of all those jars. And for that, we have the Maven dependency plugin. And Maven dependency plugin will go through the code, go through all the jar files, and will actually use the Java 9 code to detect the specified name. And since everything is still just a jar without a module descriptor, the name of the module will be based on the file name. So here you see, for example, Xerxes impl, and the module name will be just Xerxes impl. When I was working on this demo, I was quite surprised that JDOM does that module name. And well, okay, but I was wondering why. So I added some extra code to it. And here you can see there are some issues with JDOM, and it has a class in the top level directory. So that means that this version of JDOM will never ever work as a module, and you can never use it. Also, these Geronimo jar files, they cannot be translated to a valid module name because of the number inside the number in the file name. So again, those jars can never be referenced to as a module. We have also these two jars, but these are, of course, part of the multi-module project. And right now it is not yet a jar, so it cannot know the real module name because, or to discover the module name, you need the jar file. So what we can do is, instead of using compile, we can use patch. So in that case, we are not just compiling the code, but also making the jar. Okay, so you will see that we will get an actually module name. So here you see simple weather, and here Maven model book simple model. Okay, so this is maybe not what you would have expected, but also maybe you see it clear. The auto way of writing, it is done with brackets, and this has to do with one of the latest features, and that it is now possible to specify your module name inside a manifest file. So here it is empty, but you can specify it here with the Maven jar plugin. You specify one of the Maven entries saying automatic module name, and here you specify the module name. So this makes it possible for especially library builders to already say, well, if you want to use my jar, you can use this name as the new module name. And you can do this because all these other dependencies aren't modules yet. So this is something where you can go from the middle to the top. So especially if you are application builders, I think most of you are, in this way you can specify or you can use a reference by using this name. And for library builders, this is the way to do it, unless your dependencies are all modules. In that case, you can specify your module descriptor like this, specify your name here again, including all the requirements, etc. So let's try to make it a real module. And this one doesn't have a lot of dependencies, so let's try to change this. I will rename it to Java. And the module info file always have to be compiled with Java 9 as the source, target, or release. So all the other code can still be compiled with Java 5 as you want it, but especially this file needs to be compiled with as a Java 9 file. So we need to change a little bit in our home file, and that's this part. So we're going to have two execution blocks. The first one is compiling everything, including the module descriptor. And the second one is running all the files except module info.java, and it's using the default value for source and target being 1.5. And as you can see, the first one has this value release now. Nope, that's not what I wanted to do. Compile. Let's see, it has an invalid flag. This is not what I was expecting. You're still using Java 8. That's weird. That's always the problem with demos, of course. Let's see if I understand what's happening. This is weird. Okay, so what you would see when this was succeeding is you will have a lot of issues with Hibernate. And the reason is that these are quite old dependencies. Here, these two. And they have packages which exist in both jars. So that's called the split package issue. And that's not allowed in Java 9 anymore. So this means that you cannot transform this project to a Java 9 modularized project. And that's fine. Because as said, the class path will stay there forever. And you should really wonder if it is worth it to transform your code to a modularized project. If you start a new project, of course, you know all the new rules. You know that about the split package issues, etc. And that's fine. If you want to go with old projects, well, actually Maven made it already possible to make very stable builds and stable jar and WAR files. So maybe you could also say, well, maybe Jigsaw was 10 years too late, because right now Maven has made it possible to make quite stable deliverables. But well, that's the situation right now. I think that's almost everything I wanted to show you. Yes. So who can I hand over to talk? I think we have a Q&A planned, right?
Yeah, we have a Q&A next up on the agenda. So if I can, why don't we share cameras?
Yeah.
And we need to get some audio from London.
Excellent.
Okay.
While we're trying to share the cameras, maybe we have a question about Maven in Java 9.
Yeah.
So when you say Maven works with Java 9, right? Do you actually mean that you can make Maven work on specific projects with Java 9? Or do
now we can hear you, Oleg.
Excellent. Did I mute myself?
You have to start all over again.
Yeah, exactly. So like while I was listening to that, there were a couple of things that were new to me with this whole Maven Java 9 thing. But when you say Maven works with Java 9, do you mean that you can make it work on specific projects, or that you will take a Maven project, you will upgrade to Java 9, and the build will run and, well, succeed?
Java 9 of Maven itself runs fine on Java 9. So that was, I think, always the issue. where everybody was complaining or they were thinking that Java of Maven wasn't running on Java 9. But that's not the issue. And also, right now it is possible to compile code with Java 9 as well, including the module descriptor, etc. And also the nice thing about this is that you don't have to change your module structure. If you look at the example done by Simon, he had just a source and had to specify there his module info file. With Maven, you can just keep your source main Java and put your module info file there, and it will work out of the box.
You're actually then maintaining a double hierarchy there, right? Because you've got your dependencies or your dependency management section, your Maven files, as well as the module info. You've got duplication of information.
There is some sort of duplication, but some of the requirements you cannot, those are not dependencies. For instance, those inside Java, the XML and the JDK, for instance. So you cannot fill the complete requirements list just based on the dependencies. So the question, can you generate that module descriptor? Well, probably for 80%. But we're saying, well, if it's just 80%, we're not going to do it. We want to do it for the full 100% or not. So we've decided to do it not.
Okay.
Does that answer your question?
Not really. Maybe I can be more direct. So if I have a project, Maven project, Java 8, working fine, building fine, running tests fine, and deploying to the jar file or my war file somewhere to the artifact repository, all fine. I get Java 9, I install it on my machine, I change the source configuration and the target configuration. I type Maven clean install. Does it succeed?
Yeah. Doesn't succeed. That's possible.
Yeah, but like, do you think it will succeed in like with probability more than 50%? Or like, will it succeed on the Hello World project? Or if I have like a large bank application with 20 years of legacy?
Right. I think quite a lot of projects will break.
Okay, so like, in a nutshell, it doesn't work.
If that's your definition, but that's not a Maven issue. It's just about, can my Java 8 project be converted to a Java 9 project? It has nothing to do with Maven itself.
Well, you're substituting a little bit. I mean, if I have a working project and then I upgrade Maven to the latest version and I upgrade Java to the latest version, and I do the minimal configuration that I think I should do, right? Just saying that, oh, now I want to use Java 9. And if it breaks, then someone is to blame. So who do you think is here to blame? Java 9 release, Maven release, or the project?
I think it's okay. I don't think it's Maven. So okay. Maybe it's Java 9 because they decided to break backwards compatibility. So that's the whole issue. Also, during the game, those rules has changed. So if I was a Java 6 developer, I wasn't aware of those rules coming with Java 9. So why did I have to suffer about those split package issue? I wasn't aware of it. So right now I am, and that means that yes, as a developer, I can hit issues in these kind of projects.
And in a large part, purists will say, which I'm not one of them, purists will say that it's not actually a backwards compatibility issue that has made the APIs kind of non-available anymore. They were genuinely APIs which people did say you shouldn't be using. It just so happened that vast amounts of the ecosystem were using that, and I would argue when vast amounts of the ecosystem depend on it and there is no substitute to use for it, people will continue to use it irrespective. So I would, yeah.
That's true if you are talking about usage of the unsafe, for instance. But I'm talking about split packaging.
Okay.
Which was very good practice if you wanted to actually try and encapsulate some of your stuff, because it had no such things as private packages or anything like that. So that was the best way of doing it.
Right.
Yeah.
Also, Maven itself will never ever become a modularized project right now, because one of the jars we have, it's called Maven Compat. It is there for compatibility. And what we do, if there is deprecated code, we are going to shift it to that jar. So that means that there will be a split package issue always inside Maven itself.
Actually, inside the JDK, you've got similar issues, right? So they found out at the last minute, okay, we're still going to have to provide people some disk unsafe. Well, we'll put it in its own special module. But they're intending on moving things out, which basically will mean that the packages of those classes will be renamed. So it's going to be breaking compatibility there as well.
So, other questions?
Not that many, but there is one, for instance, just coming in. By looking at the demo, maybe stuff, there are now 2 places to manage. One in module.info, and the other the Maven dependencies.
Yes.
So
I think we've already discussed that part. And
briefly.
So I'm pretty sure there are some open source developers which will say, well, I can do that. Of course, they can do that for their own projects. But there are a number of, if you want to use modules of the JDK or from Java itself, you always have to specify it as a requirement inside your module descriptor. So it's not a dependency. And for that reason, it is not possible for Maven to to build that module descriptor.
I don't understand that. I mean, you've got a modules dependency feature in there. Why not just add the information that you need to generate that, so that you can? Yeah. So add a bit more metadata to your module dependency section.
So the POM file, it has an XSD, so it has a very strict setup, and Maven is not the only tool using the POM file. So, and we don't know if others are really verifying if that POM file is valid or not. So, also, all the dependencies available in Maven Central are not always coming from Maven.
Just bear with me. You only need this at compile time. You don't need the delivered POM to contain any of this information. You only need it at compile time to generate your module.info. Right?
So what about those Java? I see what you mean. No, right now it is not possible, because the POM file you have, you are using during the build, is exactly copied to Maven Central. So yes, that's one of my wishes, to change that, to be able to have a separate build POM, and we call it consumer POM. So consumer POM is the one being published to Maven Central, and that will only contain actually dependency management stuff.
But okay, so suppose we were stuck with publishing the exact POM that you built with. What would be the harm of adding some attributes to the module dependency section?
Probably not.
So please. I like my code dry, and I like my build structure dry as well.
But then you only have solved the requirements part. So what about the export part?
What about that in there as well? Just so I can manage it in one place and one place only, so I don't have to have dual structure.
Yeah, and right now the only place is the module descriptor.
Yeah.
So right now there's no solution for that.
There's another question from Oleg himself, and he's being the devil's advocate here. Sure. Is it easier to migrate Gradle or convert the Maven project? I think that's a nice one for you, Robert.
I'm not Be honest. Be honest. Well, I think one of the my feeling is that one of the reasons of the killer switch, or why they reduced the strictness, is because Gradle had a lot of issues being able to run on Java 9. That's my feeling. I'm not sure about it, but I know that both Maven and we're doing great with Java 9. And the Jigsaw team really had issues trying to run all those great projects.
Surely it was the JBoss crowd, wasn't it? A Red Hat. We were just dragging their heels there towards the end.
Maybe.
I don't think it was the Gradle guys. I think they've been ready for quite some time.
Okay.
Yeah. I might be wrong on that one.
Maybe.
I'm also, since I'm on this Hangout, I can support my question and expand it a bit. I'm also interested in all the Maven plugins that a typical project runs, like Java Docs, Site, Progward, all the obfuscation, all that stuff that has been accumulated over, say, last 5 years, maybe not even like 20, let's be reasonable here, 5 years, the modern best practices in running your Maven project. Are all those plugins, will they work out of the box? Does Maven team like work on making them compatible? Is there a status or something?
Yes, absolutely. So go to s.apache.org/maven-j9, and you will go to a wiki page where we keep all our plugin information. So maybe I can show that. I think that should be possible. If I write it correctly. And I still have to share, probably. Hangouts.
It's okay, you're sharing already.
Okay, you already saw it. So here we have a long list of all the Maven plugins which had issues with Java 9. Or which required new options. For instance, the Maven compiler plugin, of course, had to be updated to support that release flag, which is now available. And it also has to be able to know which dependencies, or actually which jars, should be put on the class path and which should be put on the module path. So, of course, that required a new Maven compiler plugin. And this is the whole list of those plugins. Then, Maven itself is also using a lot of third-party libraries, so we are depending on those dependencies as well, that they become Java 9 compatible. Finally, this ASM, I think it was released a couple of weeks ago and pushed to Maven Central, and that means that right now we can finally work on, I think, about 5 plugins which were depending on ASM.
Just use method handles. Just use method handles, I said. Don't use ASM anymore.
Well, upgrading to ASM is for us much easier right now.
Yeah,
and if we want to have most plugins available at the launch date of 21st of September, then we just have to do it this way. And maybe in the future we can think of other solutions.
Mm-hmm.
So, yes.
Sure. I'm relatively new to Java 8. I was wondering about IDE integration.
Yeah.
So I was thinking about, would it be like if you use like a classroom package and you want to use it, will the IDE suggest to put it into a module info? As person will suggest something like that?
Okay.
Maybe repeat the question
Yes, I see. Yeah. So the question is, what about IDE support? I think Simon already showed something in IntelliJ, and I can also show it in Eclipse. So maybe Simon, you can do a small demo of IDE support for Java 9.
Yeah, I can show you. Actually, I think I may have just closed IntelliJ. Get IntelliJ back up and running. So let me share my screen. So IntelliJ is just loading up.
Just don't do the presentation mode, please. It splits.
Actually, that was because I actually zoomed in, but forgot I zoomed in. There's a user error. But yeah, I'm using IntelliJ. What am I using? 2017.2, I think. .2, yeah. But I think it's been in IntelliJ since .1 maybe. It's fairly straightforward actually. I mean, from my goodness, there we go.
Trisha G gave a wonderful demo actually on the IntelliJ website.
Okay. Yes, she did actually. So in fact, I did look at that before creating this demo a while back. But yeah, I mean, we have our project here, and I can from here if I wanted to. From here, if I wanted to, I can. If I right click, oh my goodness, my machine's being a bit slow. I can create a. Where is it? I was pretty sure I could create a new module from here. Oh, there you go. Sorry, a new module from here. This would actually turn into a Java module, and from within a Java module, I can actually from here I can right click and then create a new somewhere. Perhaps one because one already exists, I can't create it. But here I can actually create a new modulinfo.java file. Perhaps if I delete, or maybe I need to do it from here. Sorry, that was a package info. If I delete this modulinfo.java, I should be able to, I think, right click from here, click new. There you go. There's a new modulinfo.java, so I can view that. Can people see what I'm showing?
Yeah.
Yeah, you can. Okay. And yeah,
you know if there are any inspections around these?
Say again,
Simon. Any IntelliJ inspections around these? Do you know?
I'm not actually sure, to be honest, if there are IntelliJ inspections. I think there are. Yes, I do believe there are.
Ah.
One thing actually I will show you as well is one thing you will need to do is you'll need. Actually, no, it's not that. What I want to do is I want to go to my where is it? To the module settings. In my module settings, a couple of things you'll need to do is you'll actually need to check here to state that you are requiring other modules as well. So right now, I'm not sure if this has changed or not, but you actually have to do it twice. Once here, and then also write down your requires in here. But then once that's done, you can
because IntelliJ, just like Maven, needs to know which versions to bring in, I guess.
Yeah, that's true. That's very true.
Sorry to interrupt. Simon, can you please focus your screen so that it gets shared to the video? Otherwise, it jumps back and forth between whoever is talking.
Oh, sure, yeah.
Thank you.
Hang on, let me. There. Is that better?
Lovely.
Okay, so yeah, so if people didn't see that, then if I right click here and actually go to my open module settings, within your modules, you can see this is just your normal kind of IntelliJ modules. From here, you actually need to state which modules you actually have a dependency on. And for those who didn't see, if I delete this, what I can actually do from here. This is recognized as a Java 9 module, and I can just go in, create new, not that, sorry, here, new, and create myself. No, it's not allowing me to do it. That's frustrating. I literally just did it. There we go, modulinfo.java. So you can create your module info there, and yeah, it will check for things. So for example, in this case, my module name is org.0 turnaround.api. If I was to go into, in fact, right now I'm not exporting my service. So if I was to go into the provider and have a look at this code. Right now we're saying you're getting the error that the module, if I zoom in, you might better see that a little bit better. The module does not export the package. So you're getting all the usual checking and things like that around the module system within IntelliJ as well. And like I say, all you need to do is hit play on that. In fact, it possibly won't work. No, it won't because of that module error. But yeah, you can hit play and it will just automatically run it as modules. One thing it will do is it'll only add resolved modules into the runtime. So you have to be a little bit careful as to if you want to make sure modules that aren't being passed from the main module which you're executing. If you want that in, you need to execute some add modules. That was one of the tricks that I couldn't find out how to do in IntelliJ, so I just added a requires. It's a bit of a dirty hack for this demo, but I'm sure there's a way. I just need to find it.
Okay, I can show it for Eclipse as well. So in case of Eclipse, one of the things you have to do is you have to go to the Eclipse Marketplace and you have to download this Java 9 support. It's a beta for Oxygen. So I already have installed it. And next you also have to be sure that you are running on Java 9, of course. So this here will detect it. And from that on, you notice that there are no warnings on this file anymore. And well, there's of course support users. And I'm not sure if it's, well, this can do all this stuff again. Actually, I'm also I know what happened with my issue. I forgot to save the POM file, and once I saved the POM file and I did make compile again, you will see that this is the issue from Hibernate. So yes, the unnamed module has a package which is available in multiple jar files. Yeah. So this is the reason why this project cannot become a modularized project as it is right now, unless you either upgrade Hibernate jars to a much newer version, or you just accept that it will stay on the class path forever.
Okay, so now, actually summing up, you've actually now got 3 module hierarchies that you've got to manage. You've got your IDEs one, you've got your build systems one, and you've got the modules. Pretty much. So where was Eclipse looking for those modules? Do you know where?
No.
It was doing some auto-completion there, so it's going to be doing it from something. Is it doing it from the Maven dependencies, or is it adding anything that it knows about?
For the requires, it doesn't have support.
Right, okay.
So, but for the exports, I think.
Right.
Exports, it gives all the packages, which I think is a bit too much.
Yeah. Of course, when you're editing Maven and IntelliJ, I dare say it's the same in Eclipse. It will know about everything that's in Maven Central, and it will autocomplete that. So you'd really want to...
I don't think that it is going to Maven Central.
Yeah, right.
Much. A bit too much, yes.
Yeah. No, not to query it, but looking at your .m2, looking at what you've got already in your .m2.
In your local?
Yeah.
That should be possible, yes, of course.
Okay. Maybe we should round up this Q&A.
Okay.
With, one last question. Someone asked, what is the main feature that will attract developers to move to Java 9, given all the possible problems we just encountered? So what do you think?
I think there's a lot of hype around reactive streams. I think that's going to get a lot of people excited. A new paradigm in programming almost. Not quite as much a game changer, or not as large of a change as going from 7 to 8 with lambdas, but I think reactive streams is going to be a big thing. But also I'm actually quite excited about some of the performance improvements that we'll be getting just out of the box, and the promises that holds for the future for future deliveries of the platform, because all these method handles and var handles things, the library makers are going to get their hands wet on that one, and probably get some pretty nice performance improvements there.
Okay. Robert, your favorite?
I would go for the release flag. Yes, and not for Jigsaw, because I think that people are not always aware of these kind of issues when you're compiling with a different version compared to what you are really running with. And you can have a lot of surprises right now if you don't use the proper setup of source target, and you don't, for instance, check if all those methods are really available at runtime. So it is a very, very strong feature, I think.
Okay. Simon, Oleg, do you have any?
So for me,
win over anyone?
For me, I think there are a lot of interesting smaller features, but I don't think necessarily that there is a big killer feature that is enough to warrant people to say, you know what, this is enough of a reason to move up to Java 9. I think actually it's going to be duller features, or not duller features, but duller reasons why people are actually going to move, which is things like lack of support, public release support from Oracle or whatever. It's going to be those kind of things which are going to drive it more than the fact that, you know, let's take Java 8 as an example. Things like lambdas, things like streams. There was such sexy things in Java 8 which made developers really want to move up to Java 8. Right now, I think it's a kind of dangerous state in that we're shipping a Java release whereby there is going to be a lot of backwards compatibility issues, irrespective of who's to blame, using whichever APIs or whatever. It doesn't really matter. It's going to be a mixed bag of people moving up. So I feel we're going to see a slower adoption of Java 9 than we have done in many previous releases. I think a lot of people will be waiting for Java 10, and a lot of people, in fact, someone in IRC mentioned it earlier, they're going to sit back and wait to see what happens to other people. I think that is going to be a strong kind of trend that you'll see. But for me, yeah, there are a lot of nice small features, but they are just that small features.
Mm-hmm. Okay, thank you. I think we can conclude the Q&A with that and move on to Josh with his roundup on the Java EE 8 release.
Sure.
Josh?
How's everyone today?
Very well.
Good.
Thank you.
I'll just go ahead and I'll round up the Q&A with my favorite Java 9 feature. Actually is just like Simon said, there are lots of small features that are nice. I think that things like the HTTP client was going to be a nice new feature. Also, the private methods in interfaces. That's another nice little new feature that's thrown in there. So just to kind of round it up, those are a couple of my features which would make me kind of want to move forward. But yeah, I'm kind of on the same side of the boat where I'm thinking that it probably will not be very mass amount of people going to Java 9 right away, like everyone was just kind of chomping at the bit to get on Java 8, because it was all you had more of a elegant style of programming coming your way with that functional style with streams and lambdas and everything, and now with Java 9 it is more of the dry new features. However, performance is one of the big key points to moving forward, I believe. So, and I'm interested to see how that's going to play out with the Java EE side, actually, because it is possible to run Glassfish and possibly some other Java EE servers on Java 9 right now, and there may be some performance benefits there and other things. So that's kind of what I'm interested in. But I'll start sharing my screen so that we can see my presentation here. Everybody see that?
Yeah, we can see that.
Perfect. Okay, so I call this presentation just Java EE Turnkey to Start, because basically we're right there. If we think back to, a year ago even, what was the state of Java EE? It was very up in the air. It was kind of a scary time for Java EE because we weren't quite sure what was going to happen, as far as Oracle moving forward with Java EE, if there was even going to be any activity from Oracle and others on Java EE. And it's been very healthy ever since the last Java 1, I believe. I would say since Java 1 2016. It's been full speed ahead, and we definitely are now on the heels of release with Java EE8. And so I'll just give you a quick overview in this quick presentation and show you a couple of the new features that we can look forward to. Just a little bit about me, very quickly, is that I am a DVA and developer for Fermilab in my day job. And on the nights and the weekends, I am a technical writer for Java Magazine and OTN specifically. I've written books for A-Press like Java EE recipes. I've written Java 8 and recently Java 9 recipes has been published. And I've been a member of a couple of the JSR expert groups. So again, like I said, today we're just going over a quick overview of Java EE8 specifications and their current status. I'll show you a few code examples if we have some time. What you can do though right now is you can definitely get started today just by going to download Glassfish 5. Now it was a huge sigh of relief, I think, for the Java EE community when the Glassfish builds for Glassfish 5 started to come about. And this was probably in April, I want to say. So they've really been coming along quite nicely. And actually, I think that they're releasing 2 promoted releases per week now. So, you know, really stacking in the new features. The specifications are all loaded in, and you can really pretty much download the promoted releases now and run what will be Java EE8. And you can just begin incorporating these specifications into your project. And one of the ways that you can do this is to utilize something like the Java EE8 Playground project. Now, this is a project that I put on GitHub, basically to give developers the benefit of simply downloading a project that's ready to go. It's a very basic project, doesn't give you too much out of the box. However, if you open up the POM file for this project, you can see that I've basically included all of the Java EE8 specifications. And what I've been doing is trying to update the project on occasion when the newest releases come out. So, you know, if you go to GitHub right now and look, there may be a back-leveled release here and there. So I do need to update it again. But most of the specifications are updated to their latest releases with Java EE8. And so that's a great way to get started. There are also a lot of other great examples out there. If you search around on GitHub, you'll find them. So what does Java EE8 cover? Really quickly, just gives you continued enhancements for productivity. If we think back to Java, well, we'll call it J2EE, when those days were horrible. And I'm not going to be, I'm just going to be blunt about it. They were bad. And it was hard to, you know, bring a project forward, all the configuration, the XML, it was a nightmare. And now we've got great, elegant, easy to use applications. Java EE pretty much gives you everything you need right out of the box to get started. And I would argue to say, even if you are using microservices, you can use Java EE quite easily. Better alignment with Java SE8, with the Java EE8 release. And one of the things that's always been kind of bothering those Java EE developers for the past year or so has been, you know, we can't use these Java SE8 features right away. Well, there are ways to do it, and now lots of these APIs for Java EE are coming into alignment, so we can begin to utilize things like lambdas and streams just within the APIs, and working towards a better platform for developing microservices. So, like I said, you can go ahead and develop microservices right now. However, there are going to be some features that are not fully baked in, and you'll have to do a little bit of, you know, resource gathering, and you may have to bring in a project here or there just to fill in those gaps. But with Java EE9, which is coming, Oracle says next year still, so let's keep our fingers crossed and hope that that does happen. But with Java EE9, that is supposed to be the truly compliant microservice platform. Right now, we are moving in that direction, and still quite easy to do, but you know, you may have to pull in a couple of other projects to go all the way. Now, as far as specifications go with Java EE8, it has been cleaned up a bit since the kind of refresh last fall. So we've got CDI 2.0, JSON-B, the binding specification, JSON processing, Servlet 4, JSF 2.3, JXRS 2.1, you know, bean validation, and security, which is, in my opinion, one of the most important, security 1.0. There are some maintenance releases that are coming into play as well, JXP 2.0, JPA 2.2, and we've got Java mail and interceptors. So lots of change, and not only with Java EE and the specifications and everything, we've had to deal with the Java.NET close down. This was a big deal for Java EE because all the specifications were run basically on the the Java.NET mailing list and throughout the Java.NET website. Now, most everything has been moved to GitHub, which is a great benefit, I believe, for the platform. And the mailing list communication channels have changed. If you go to GitHub, you can actually see the different Java EE specifications now. If you go to the central location, and most of them have information about how to join mailing lists and whatnot. However, now we are ramping up with most of the specifications, so you know, there's not going to be much more email going on the expert groups too much forward here. So let's dive into Servlet 4.0. It's now at the final approval ballot. What does it bring us? Well, this is one of the most important specifications along with security because really this is underlying almost all of the web technology for Java EE. And so almost everything uses Servlet, and we're really going to be getting lots of performance enhancements with Servlet 4.0 with the request response multiplexing. We can now prioritize streams. Server push HTTP 2 support is one of the biggest deals. We can really get rid of some of these old ways of doing things where we had resource issues and all the different back and forth with the request and response. Now we can go ahead and send resources over one wire with one request, and we can do this with something called server push. I'll show you real quick in some code how we would do something like that. So if I take a look at this servlet here, now with Java EE8, we're going to have this push builder, and you can build this push builder from a request, and we can go ahead and add resources with the push builder and push it all at once. So if I had one or more, GIF files or JPEGs, or this would include CSS, JS, any files that we want to push in mass, so that the client doesn't have to sit there and wait for these resources to load, we can go ahead and push them with the push builder. And something that's very nice with the push API is that it looks at the browser cache to see if these resources have already been loaded. If they are, it does not attempt to load them again. So very nice how they've done this, implemented this. Let's go back to the presentation here, and we'll take a look at CDI 2.0. This is a major release for CDI. The focus has been on modularizing it, adding support for Java SE. So now there are actually two different components. Now you've got the Java SE implementation and the EE. And so what does this bring? We can now order observers. We can do asynchronous events, configurators for the SPI elements. We can configure or veto observer methods and much more with the Java 8 alignment and whatnot. So quickly here, just to show something we can do with the async is, in this particular situation, what I'm doing is I'm calling upon a persist method, and what I'm going to do is just basically persist a database record. And when it is persisted, you can see that I'm using this event, and I'm calling fire async. This is part of the new CDI API. Now, this will go ahead and it'll fire when it is completed, then it will bring back an event, and we can go ahead and do whatever processing we need to do once that job has completed. Since it's asynchronous, it's going to return processing right away to the requester, and they can continue to do whatever tasks that they were doing, and this will run in the background. So this is a very nice thing to have. There's also another feature that I wanted to show you with CDI, and this is a standalone project. You can actually go ahead and download sources to this online. There are quite a few actually implementations of standalone CDI examples out there. This is just a brief one. What you would do is basically set up this SE container initializer, get a new instance of it, and here I'm basically firing event, and this is a person event. I'm not going to dig into all the code, but I'll quickly show you that when I run this code, it basically builds the person object, and it fires some events which add people to a list. If I could pull this up here, you can see that these people have been added to the list using this people populator. And this is all using CDI. And this is in Java SE. So this is the Java SE support for CDI, which I think is going to be a great boon. Now let's move right along. And we'll take a look at JSON-B. This is the JSON binding API. Another new one. I'm not going to go into any more code because I know I am running up to close on time. But what this will allow you to do is serialize and deserialize objects to and from JSON. So really nice, easy to use. So if I've got a list of objects, let's say, and I want to quickly put this into JSON format, you just basically call upon a JSON binder and a JSON builder, and you create a JSON object and simply pass these this list of objects to it, and it will change it into a JSON string. Let me see here if I can really quickly demonstrate. So I've got this list of customers in the Acme Pools application that is on GitHub, and what I can do is press this get JSON, and this is basically what it's doing. It's using that JSON builder to get these records into JSON format. JSON processing, this is really a great, small release, but a great release because it brings JSON pointer and JSON patch functionality. What this will allow you to do is point to a specific element in your JSON, and the patch will allow you to change those elements. So let's say that I've got a third element and I've got an address that I would like to change in that specific JSON element. I can go ahead and do that quite easily now. We also can do editing and transformation of operations using the JSON object model and better alignment with Java SE8. Very nice. JSF 2.3, this is a huge release for JSF, although it was just a point release. I really want to put it out there for the community, especially the OmniFaces folks, and also the spec leads for JSF did a great job moving things forward. We have enhanced CDI alignment. You can now inject JSF resources into your objects like the faces config and whatnot. We've got WebSocket integration, Java 8 date time. So now I can use the regular convert date time tags like you do in JSF, and it will use the Java 8 date time API, which is really nice. This goes hand in hand with the new JPA maintenance release, which now supports the Java 8 date time. JAX-RS 2.1 is now final approval, server sent events, improved CDI integration, a reactive client API, and non-blocking IO. So very nice improvements there. Bean validation 2.0, this is also a final release now, and it brings improved support for the datetime types and better SA alignment. Lots of new built-in constraints and repeatable annotation support, which I think is quite needed. Now, for the security API, basically what this is going to do is provide you a standard way to do authentication against a database, LDAP, or embedded. So very nice. And we also have authentication mechanism, which will give people the option to go to a standard way of doing authentication rather than using their individual vendors supported way with the different servers. And actually, I want to just take a quick moment to say that if you go to the reference API, I can't believe I'm saying it the wrong way probably, but Soteria, I believe is how it's pronounced. I could be wrong there. You can see here, security Soteria at GitHub. They've got a ton of tests. So you can go and take a look at the code, dive right into it. Now, JPA 2.2, I wanted to quickly mention this because stream support, Java 8 date time. This is just a big benefit to those who use even different frameworks. Even if you don't use Java EE straight up and you use Spring or something, you still use JPA. So this is a great improvement. Real quickly, Java EE Guardians is a group that I belong to, and we are moving things forward to Java EE 9 now. We want to make sure that the future of Java EE is really upheld. So if you're interested in, helping along with that, then go ahead and visit the site. And if you want to learn more, again, I've got to put a shout out to CJug and to Freddie Gimme and Bob Poland. They do a great podcast called the Java Pub House. And you can listen to that and learn lots of new tricks in Java Off Heap, where we go ahead and discuss lots of Java news. You've also got the great other podcasts out there as well. So that's just a little bit about Java EE from me. I appreciate it. If anybody's got any questions, I'd be happy to answer them.
Do you guys have any questions while I'm setting up the slides here?
I haven't seen any questions coming in through Twitter. So,
is it how far along is the production ready?
Okay, Josh, question from the audience here. How far along is it production-wise?
Into production ready.
When can people expect to use Java EE 8 in production?
Okay, so right now, if you go to the JSR 366, it says H2, so that would be half 2 of 2017. And I speculate that they're going to release it Java 1 timeframe or shortly thereafter. Everything is almost at final release. If not final release, it's at final approval ballot stage. So very close, very close.
And how long after that do you foresee vendors to actually pick up?
Well, if we look back at the adoption rate for Java EE 7, of course, Glassfish will be there right away. Probably servers like Pyara, which are pretty much adaptations of Glassfish. Those will move along quite nicely, probably within a couple of months. But if you take a look at servers such as like WebLogic possibly, and some of the other, bigger name servers, those may take a little longer. So anywhere from 6 months to a year probably for them to adopt.
Okay, thank you very much, Josh, for the update.
I appreciate it.
And before we close up, we still have a couple of announcements, because every jug that's participating in this event is, of course, following up with some things. Hoping this comes up on screen.
Yeah, it's on.
Yeah, I just can't show it for whatever reason. Right. Yeah, well, does that work? Yes, it did.
Yeah,
except this go to the beginning. Yes. Yay! Oh.
One back.
Oh. Technology. Sheesh.
Getting there.
There we go.
Yes, there we are. Okay. So the virtual jug will be following up with a virtual hack day, actually. So if you really want to get some hands-on experience with Java 9, next Saturday, so not coming Saturday, but next Saturday, there will be an entire day that you can practice using Java 9. Simon, anything to add?
Yeah, so we're going to be covering modules, JLink, and also JShell. So we'll have a short amount of presentation, but the vast majority will be around some sample code that we're going to be hacking and playing with and building. And one of the big pieces of value from it is to actually provide feedback on each of the features. So yeah, that'll be myself. Actually, I'm traveling to the US tomorrow, and I'll be in Atlanta for this with the Atlanta Jug. And we'll also have Heather Van Cura, the JCP chair, present in Atlanta, and we'll also have Manny, who many of you may have chatted to in IRC today. So yeah, we'll be there next weekend. Looking forward to it. It's a 6-hour hack day.
Okay, so if you want to get some hands-on experience, go join them. The Chicago Jug has a nice event planned for using Docker. So if you really want to know the ins and outs of how to use Docker, use Java, then...
we also just announced another meetup. Actually, that's not until October, but we've got Brian Goods coming in. He's going to be telling us about the future of Java.
Wow.
That's October 23rd. Okay. We'll be actually speaking from my office's headquarters, IMC in Chicago.
I actually saw a very similar session that he gave for the London Jug, and I will massively recommend that. So anyone who's in that area, yes, please do go and see that. That's a really great session.
Yeah. Okay, very good. And for the NL Jug, we actually will have a number of events surrounding JSON binding. Josh just mentioned it as one of the updates in Java EE8. And that'll be end of the month, beginning of next month, at a number of venues. So if you're interested in that, please keep our NL Jug website in check, and we'll give you some announcements there. So that's basically it for us. Thank you for watching. Simon?
Yeah, thank you everyone for attending. This session has been recorded and will be available on the Virtual Jug YouTube account. So do check that out, and obviously anyone can embed that. So feel free for the C Jug and the NL Jug to share that wherever you wish. That's it, everyone. Thank you very, very much for attending. Thank you to in fact the team there, Maurice, Bert, Robert, and Jonathan and Josh as well, and Oleg, who unfortunately had to leave a little bit early. But thank you everyone for attending and making this a great event. So thanks everyone, and see you next time. Bye.
Okay, you're having us. Bye.